Hi, welcome back. We all know how to find out eccentricity in case of a standard ellipse. In this video, we'll be discussing how to find eccentricity when the ellipse is general in nature. These type of questions are asked in competitive exams and this trick will really help you. So let's start the video. Now I need to solve this question really fast. Let's see how we can do. Okay. The question is find the eccentricity and center for the following ellipse. The ellipse equation is not of the standard format. The standard ellipse equation is of the form x square by a square plus y square by b square equal to 1. But clearly this is not that type. Now I need to quickly find out the eccentricity for these type of ellipse. So the first one, I will write the answer. Answer will be, it should be root 5 by 3. Similarly, the second one, it should be 4 by 5. And the third one, the answer should be root 3 by 2. That should be the answer. Similarly, I can also write the center using a magic trick. The center for the first one should be 2, minus 1. Center for the second one should be 3, 5. And for the third one, the center should be minus 1, minus 2. You want to know how? Let's find out. So the trick is that for these type of ellipse equation, the eccentricity is under root of 1 minus a upon b. Now notice that a should be less than b, otherwise this fraction will be greater than 1 and we'll get a negative value inside the root sign, which is not possible. So care must be taken while substituting the values, that whichever is smaller that we will write in the numerator and the bigger quantity we will write in the denominator. So let's take an example. Here in this case, if I want to write eccentricity, that will be 1 minus 4 by 9, which will be equal to root 5 by 3. So straight away that is the answer. Now in order to find out the center, what we can do is simply divide the coefficient of x by coefficient of x square. So I will write minus of minus 16 divided by 2 into 4. Similarly, divide the y coefficient by y coefficient. So therefore I will write minus 18 divided by 2 into 9. Therefore the center should be, this is plus 16 by 8, which is 2, and then here we will get minus 1. So that is the answer. Easy, right? Let's try another example. So here in this case, E should be equal to 1 minus smaller by bigger. So I will write like this. This is 16 by 25, which is equal to 4 by 5. So that is the eccentricity. Always remember, for ellipse, the eccentricity should be between 0 and 1. So here clearly it is between 0 and 1, so we will accept it as the eccentricity. The center, if you want to find the center, so it will be minus g, so I will write minus or minus 150, divide by 2 into coefficient of x, which is 25. Similarly, y coordinate will be minus of minus 90 divided by coefficient of y square, twice of coefficient of y square, which is 2 times 9. So answer will be 150 divided by 50, 90 by 18. So you can write 3, 5. That is the answer. So let's take another example. Here in this case, E should be equal to 1 minus smaller by bigger. So we will write this as 3 by 4. So answer should be root 3 by 2. The center for this ellipse will be equal to minus coefficient of x divided by coefficient of x square, twice of coefficient of x square. Similarly, next is minus 16 divided by 2 times of coefficient of y square. So answer is, this is minus 2 by 2, it is minus 1, and here it is minus 2. So that is the answer. So I'm sure now you're ready to do many questions of these type. So let's see why it happens. Let's take the equation of general ellipse whose axis is parallel to coordinate axis as ax square plus by square plus gx plus fy plus c. Now I'm going to use the perfect square method. So let's first collect all the terms containing x on one side and y on the other side. I will shift the constant c to the right side. Now here I am going to make it a perfect square. So let's take first a common. So I will write like this. Here let's take b common. So I will write like this. Now in order to make the first bracket a perfect square, I will add g square by 4a square. Similarly on this side we'll add f square by 4b square, and in order to balance it I am going to add the same quantity on the right side. Note here that this a will get multiplied with 4a square and will generate 4a. So that's why I added 4a on the right side. Now we have a perfect square. X plus g by 2a whole square plus b times y plus f by 2b whole square is equal to some constant. Let's call it as k. Therefore, the equation of ellipse changes to equal to 1. Now we can easily see that the center is obtained by equating this bracket and this bracket to 0. So the center should be minus g by 2a and minus f by 2b. This is what we were using in the trick. Similarly, if we want to find eccentricity, so e square is equal to 1 minus b square by a square. Now here in this case, if I take this quantity as capital A square and I take this quantity as capital B square, we can write this as 1 minus k upon b divided by k upon a. K and k will cancel out and we'll get 1 upon a upon b. That's why e is equal to root of 1 minus a by b. Here in this case, care must be taken that a is always less than b. So this is the proof behind our trick. Hope you have understood the concept now. So if you have understood this trick, then write the answer to this question in the comment section.